So, good morning. Myself, Aram Rajeshwari, Associate Professor, Department of Artificial Intelligence and Data Science, Dropout Institute of Technology. Today, we are going to see about the dropout in machine learning. And this is a very important concept in the concept of neural networks also. So, here, a dropout is a regularization technique used to prevent overfitting in deep learning models, especially in neural networks. It was introduced by Jeffrey Hinton and his team in 2012 and has since become a widely used method to improve the performance and generalization of the neural networks. So we must know what is dropout. A dropout works by randomly setting a fraction of inputs unit to zero at each training step. The idea is that this steps helps to prevent the model from becoming overly reliant on any specific neuron or feature training during training. By doing so, the model learns to generalize better rather than memorizing or overfitting the training data. So here the logic is you are going to stop the neurons which are which has more weight, but it is not relevant to that particular feature. So we are going to drop the particular features only. So this is a technique in which we can better drop out the neuron and its connections, which does not have a greater impact on that particular time. So this is the main concept that we will discuss later. So here, how does dropout works? So here, you must know what is the advantage. What are the advantages of the dropout? So here, it reduces a overfitting concept. It helps the model generalize better by preventing it from overfitting the training data, as well as it is simply to implement. That is, the dropout can be easily added to the neural network with minimal additional complexity, and then works across the various models. That is, the dropouts can be we can apply to the neural networks with any feed forward or recurrent neural networks, including the CNN as well as the LSTM also. So these are several disadvantages. So there are some possible disadvantages also, but it is not it does not have a greater impact on the compared to the performance provided by the dropout. That is there are slower training. That is, the dropout can slow down the training process because at each iteration a part of the network is effectively disabled, which means the network um, might need some what else we can some more, might need more approaches to converge. Not always optimal. In some cases, the other regularization techniques like batch normalization or early stopping may work better or in conjunction with that of the dropout. So we can so these are the techniques that I have not mentioned in this slide, but it will have the opportunity to delve deeper into them in the next semester itself. So here just why we need that. So it's like an ensemble. It acts like an ensemble learning. So we can know, we already know about the ensemble learning in third unit, in which bagging, boosting, as well as stacking concept is also there, as well as it reduces co-adaptation, in which it works together perfectly, which can reduce the robustness. So these are the some essential features or the characteristics of the dropout that must need. Okay, next one is the phases of the dropout. So we are here, we are two phases. One is a training phase and one is a testing phase. The testing phase is also called as a training, the inference phase. So in the training phase, for each training batch, a random subset of the neurons is set to zero. Actually, whatever it may be, the value is between 0 to 1. Okay, whatever, whether you are going to assign any value or any weight or bias value to that particular neuron, it must be between 0 to 1, because the probability value occurs between 0 to 1 right now. We already studied the probability and statistics lab, statistics, mathematical subjects. You know the probability is always between 0 less than or equal to x less than or equal to 1. So this logic is used in the dropout also. So here we are assigning several weights. There are some default weights also as assigned provided by the inventors itself. But here we are using normally it uses the probability range of 0.5. Okay, so here first one is a next one is a training testing phase. Here, during testing or inference, no neurons are dropped. Only it is dropped only at the stage of the training phase only. No neurons are dropped in the testing phase. Remember. So this is the important part here. So here the outputs are scaled by the dropout ratio to match the expected outputs from the training. That is here a random deactivation, scaling, and functions of neurons dropped are the main factors that influences this two testing phase. First one is two phases. One is the training phase, and another testing phase. So these phases mainly depends upon random deactivation, scaling, and fraction of neurons dropped. That is, during each training iteration, a specified percentage of those neurons are dropped out. That is set to zero randomly. This means that these neurons do not participate in the forward or the backward propagation for that particular iteration. So scaling during testing or interference, all the neurons are kept, but their outputs are scaled down by the same dropout rate. This ensures that the network's behavior during training and testing remains consistent. So remember, the network behavior is going to maintained in a consistent manner. So we need scaling at that time. So fraction of the neurons drop. Here, typically the dropout is applied at the layer level, and the propagation of the dropped neurons is controlled by the hyperparameter, often between normally it is between 0 to 1, but the default value is 0.2 to 0.5, I think so. So a dropout ratio of 0.5 means half of the neurons in the layers are dropped. So this was the main point discussed in this slide. The next one is mathematical logic behind the dropout. That is, let's say you have a layer with neurons x1, x2, etc. up to xn, in which you are going to apply the dropout. During each forward phase, the output of each neuron is multiplied by a binary mask. That is a vector of zeros and ones is there, where each element has a probability of p, which is usually set to 0.5. So here the output for each neuron during the training becomes output is equal to output, that is, for example, output I is equal to xi into mask, where mask I is nothing but the Bernoulli of p. So remember, the Bernoulli function plays a vital role in determining the deactivation of the neuron in the dropout mechanism. So during testing, the neurons are all active, but their activations are scaled by the dropout rate. So you have to scale the output in such a way that h dash is equal to r into h. Here, r is nothing but the hidden layer in which the Bernoulli function is applied over that. So this is the small mathematical logic behind the dropout. So next one is actually I already said no that there are some default values which are assigned by the international committee itself, but we are using some values where we can randomly choose any value only between 0 and 1. Remember, you can choose the value only between 0 and 1. So here we are using normally the input layer, the dropout rate is from 0.1 to 0.2, whereas the hidden layer, the dropout rate is 0.3 to 0.5, and the recurrent layers, that is maybe it might be a back propagation, the layers which were applied during the back propagation along with that of the output layer may involve the dropout ratio of 0.2 to 0.3. So this is the technique in which this is the dropout rates, typical dropout rates mentioned by the inventors. So here, once again, I repeat that dropout is a regularization technique used to prevent overfitting in deep learning models, especially in neural networks. So it was introduced by Srivastava of the IIT in 2012, along with that of Jeffrey Hinton. So here it widely used to improve the performance and generalization of the neural networks. So it randomly setting a fraction of input units to 0 at each training step. The idea is that this helps prevent the model from becoming reliant on any specific neuron or feature during training. So by doing so, the model learns to generalize better rather than memorizing or overfitting the training data. You know that the term, the overfitting and underfitting, if it is overfitting means The model performs well with that of the training data, but not with that of the test data. Underfitting means the model never performs good at even in training data as well as in test data. That is the basic concept behind the generalization of machine learning. So here ultimate aim of the dropout is to reduce the overfitting of the training data. So that is the mention in the previous slides. See here, you may see that here, yes, it is used to reduce the yes, the first point is it is used to prevent the overfitting. Remember, it is the main point here. So why is dropout so important? So you have to know. So that is discussed here in complex neural networks with many parameters or factors. There is a risk of overfitting to the training data. Dropout helps the overfitting by ensuring the model does not rely too much on any particular neuron. That is, remember the word, underline the word, it does not rely too much on any particular neuron or feature. So improves the next point is the improves generalization process in which the randomly drops a unit and the network is forced to learn redundant representation which help improve the model ability to generalize to see and unseen data. So that is the main that is improvement improves the generalization. Next one, increased robustness in which the model is more robust. So the neurons are dropped. The model can still perform well on those specific features, leading to more resilient models. So these are the some points that why is dropout is so important, and for this. So here I am elaborately tell that points, but you must just know what is generalization, what is relying on a particular single neuron is a repeated concept we already discussed in our previous chapters in the class. So next one is, so this is the pictorial representation of the dropout in which this is the fully connected network. You may already know that this is the hidden layers in which of it is a three layer architecture in which these layers are the hidden layers which are fully connected with each other. So it is a fully connected network and there is an output is there. So here we are going to apply the dropout. After applying the dropout, several connections are dropped or disconnected from the network because only the necessary feature, a connection which is having the necessary feature or a connection which is a more important feature is only connected with that of the output layer. Other neurons which does not have a greater impact on the output is disconnected. So by the probability of 0 to 1. So this is mentioned in this slide. So you can better understand the dropout concept by seeing this diagram in which you see that here there is a panda figure in which I assign some weights for this particular feature. Suppose if I am going to show the picture of the panda to the machine, it must correctly identify this is a photo of or a picture of the panda by specifying these features. So here I am giving the weightage to each and every features of panda. That is for the eyes, I am mentioning it is 0.8 because see here I am mentioning a weights to each and every features of the particular picture between 0 to 1. Remember, it must be 0 to 1. So this is shown here. So here the eyes has a greater impact of weightage. There's a greater weightage of 0.8. Ears is 0.4 and nose is 0.6 and color is 0.3 and tail is 0.1. Suppose if I am showing the picture of the panda like this to the machine, so it based upon the highest feature. Suppose if any animal having eyes which are encircled by the black color and it was surrounded by some white color features, it automatically identifies the picture. The given picture is the panda. Likewise, it is going to identify. Here I am giving less weightage to the tail as well as yes. Remember, tail and color is also I am giving less weightage because this is a black and white combination. So any picture which is having the black and white combination does not has the meaning that it is the picture of the panda itself. So it might be some other picture also. So I am giving So low weightage to the color. So I am giving more weightage to the eyes as well as nose, because the unique feature of the panda is the eyes, which are encircled by the black circle. So that I am giving more weightage to as well as the nose. So let us consider the scenario in such a way that let us consider this figure also. So here a panda is sleeping in a back view like that. So you can't identify the features of eyes as well as the nose here. But if you are showing this image, panda image to the machine, it must correctly identify that is a panda. But it won't happen because I am giving more weightage to eyes as well as nose. But in this picture, there is no focus on eyes as well as completely hidden off. That is, eyes and nose are not shown in this picture. So automatically, the machine sometimes the machine does not be able to identify the picture of the panda if it's shown like this. So this is the question why dropout arises. Yes. So here, not only giving importance to the, so I am going to cut the more way, I'm going to cut the connection of the eye as well as the nose when this picture comes into the mind. So okay, so I'm going to give more weightage. So here I am giving 0.8 as well as 0.6 to the this figure, because if you seeing this picture, automatically the machine identifies, so it is more weightage. So any animal which is having eyes which are encircled by black as well as the nose which are sharpy as well as black, it is identified as panda if it is shown in the front view. Suppose if it is shown in the back view, automatically the machine is fail in achieving the target. So I am cutting out that is dropping out the connection of eyes as well as nose when this picture comes into the mind. So here I am giving more weightage, because suppose here let us consider this figure. So this one is the nose, then this one is the tail, as this one is the color, and this one is the ear, eyes as well as nose. So I am going to cut this connections too, because it does not shown in this picture. Okay, correct. So here there is no eyes as well as no nose is focused on. So I am going to cut out those features which are not present in that particular picture. So this is the concept behind the dropout. So the machine can easily identify based upon the ears as well as the tail. So based upon the ear and the ears and the tail, it is going to identify the picture of the panda correctly. So this is the basic logic behind the dropout. So here in neural network, the features like eye and nose might have so that is mentioned here in this paragraph. In neural networks, features like eyes and nose might have a high importance for recognizing a panda from the front view. However, if the panda is shown from the back, these features may not be visible. So dropout helps the network become more robust by randomly dropping the features during training, encouraging it to learn from a wider set of clues. Maybe it might from the colors or the tail or the some of the gestures. You can easily identify the that is a machine. A good machine has to recognize the panda from different angles. So that is the main concept here. A good machine has to recognize correctly the panda from different angles itself. So this is the concept of the panda. Sorry. Concept of the dropout in panda picture. So here some of limitations are also there. Oh, sorry. So here, see the logic being used in panda images. The network might overfit on features like eyes or nose, which are missing in the back view. With the dropout, it mainly focuses on ears, colors, and even tail because of the during the training. So this is the concept behind the dropout in panda picture, and the limitations are there also there. Each and every technique has its own set of advantages and disadvantages. There are some disadvantages as well as limitations also. I already said that it is a slower training. Is there slower training, that is dropout can slow down the training process, because at each iteration a part of the network is effectively disabled, which means the network might need more approaches to converge and not always optimal. That is, in some cases, other regularization technique like batch normalization or early stopping may work better or in conjunction with that of the dropout. So, finally, the summary and the applications are that a dropout is a powerful technique that helps improve the generalization of deep learning models by preventing overfitting. It is widely used in industries as well as in academia. Effectively works in variety of neural network architectures. However, like any other technique, it has trade-offs. That is, the optimal usage may depend on the specific problem and the data set. So these are the techniques behind the dropout concept. Other than this, there are some regularization concept also there. But these are the techniques that we are not mentioned in this slides, but you will have the opportunity to delve deeper into them in the next semester. Just to give you a preview, I will briefly mention them here. By the time you encounter this concept, this will not be unfamiliar to you. So this is the main topic which is mentioned in this semester as well as in the next semester too. So while hearing that word, you will not be unfamiliar to that particular word. Thanks for the opportunity given. I hope you will better understand the concept. Thank you once again.